Hello, I'm Chris, and yeah, this is what we do, in a way. And we're getting away with it. And this talk is about how. I work for a small travel agency in Amsterdam. This is actually the business we are doing. It says so right on the side. We're doing online hotel reservations. That is, we're doing reservations. We're not buying rooms and selling them. We are facilitating a contract between the guest and the hotel. And then the guest is paying at the hotel. We're doing hotels. We're not doing rental cars or flights or other stuff. And we're doing only online stuff. If you can't click on it, we're not doing it. This is what the site looks like, or looks like for some customers. I will talk about that somewhat more. It is a very simple business. Basically, you tell the site where you want to stay, when you want to stay, how many people or rooms you want, and then we are proposing a number of hotels to you, and you can make a booking. It is an interesting business because most hotels worldwide are independently owned and operated. They are not part of a chain. So if it says 250,000 hotels on the website, that means that we are maintaining about 200,000 individual contracts with hoteliers. Many hotels, well, there is a vast technological difference in how you communicate with hotels. Hotels from hotel chains want to do communications with machine-to-machine communications and XML. Most independently owned and operated hotels get reservations by fax. I think we have one of the largest fax arrays in the world, and it's not for spam, it's for reservations. And if you, for example, book a hotel in China, actually there's a fax machine maybe in the village next to the village you're going to stay, and then somebody with a bicycle takes over the reservations once a day. And all of these hotels are on the same website. It is a very manual and personal intensive business, mostly not just on the hotel side, but also on the guest side, because when things go wrong, eventually they maybe require manual intervention, and the fail case is particularly nasty. Nobody wants to sleep under a bridge. So basically customer service exists and also even picks up the phone and probably speaks your language, or at least English. And they exist basically to prevent that case, that somebody has to sleep under the bridge. Find a room for the night, even when all other things go wrong. And we're doing this in very many countries and in very many languages. As a business, this is kind of the market or the area where we operate in. This is something called the Synfin model. And it's something that can be used, for example, to classify market maturity. If you look at this area here, this is basically, for example, what the internet was before the dot-com bubble. Nobody had even a business model. Nobody knew how to extract money from the internet. Then in the beginning of the dot-com bubble, you have this. You have a market where structure emerges, where there is a business model, but not yet a best practice. If the market matures even more, then you have a best practice, you have a business model, you have a best practice, and you're beginning to measure and you try to define metrics and the key performance indicators and stuff. And if you have a fully mature market, you are here, you have a playbook that basically says what to measure, how to operate, what are the appropriate responses for all kinds of business inputs, and you're trying to optimize for cost. Here, you're trying to find a model how to make money. Here you are in a market where you can't grow without only at the expense of others. So this is very cost sensitive, and this is, at least for me, an interesting part of market maturity, because you have an area where business grow rapidly, and where you when you grow, you go through a variety of phases in the business development that require reorganization and restructuring to adjust the structures in the company to deal with the new challenges in growth. This is mostly what we have been doing in the last few years. This ends for stock market reasons in 2010. And if you look at this, this is a nice straight growth line in an exponential diagram. And this is the number of hotels that are available on the site, and everything else in the business basically scales with this. This is the problem statement, or what I'm going to talk about here. It is not, or at least at this scale, not the common problem that many companies have, but it is still interesting to look at this. The topic is growth. The company growth, the structures on the technical side and also on the organizational side need adjustment, and how do you deal with it? It basically means that every year you are reaching last year's maximum business very early in the next year, and then most of the time in the year you are dealing with levels of load or size of business that has not been seen before. So you are also very likely to encounter problems and challenges that have not been an issue last year because you weren't that large. There are basically two levels of growth that you can distinguish. One is you're growing slower than Moore's law. That means that technology is growing faster than you, which is good, because it means that most likely next year you can still buy hardware that meets your needs. And the other is you're growing faster than Moore's law. That is, you're growing faster than hardware becomes faster. And you're probably also growing faster than most other businesses around you. So that means it is very likely, or even to be expected, that you will meet technical challenges that cannot be just solved by buying more powerful hardware, because you're basically outgrowing everything else around you. What makes it manageable is that the pattern of growth is predictable and stable. The business, in our case, is very seasonal. There are certain unpredictable or harder to predict influences, like Olympic Games or soccer World Cups and the moving Easter and everything that depends on the location of the Easter celebrations in the year. But basically the pattern is predictable, and the level of growth compared to the last year can be measured, and that makes at least the capacity planning for which you are planning manageable. Still, the bottlenecks you will see each year are usually not predictable, because if they were predictable you would have been planning for that and been avoiding these. So what goes wrong or almost wrong every year is something that is pretty much out of the blue. And the mission statement, the problem that you have to solve, is to build the required organizational, personal and technical structures needed to match the growth and the challenges of the current year. And note the order of things here. Technical challenges actually go last. This is the much harder problem here. It also means that whatever you're doing in the business for this year is probably not going to last. So you might as well just do it and build it in a way that it lasts a year or two. By then it will have outgrown its usefulness anyway, and you have to look at different ways of doing things. And once you embrace that and are taking this to the core of what you're doing, then actually life becomes a lot easier. I started with booking in 2006, and back then we have been less than 40 persons in IT. The people working there basically had written the site twice. They know the code. They actually also knew the host language, which is Perl. And they probably are major Perl contributors, because the company has been hiring mostly from the credits and authors file of Perl and the CPAN archive. And so basically everything that ran the site was known to the people who were writing the booking code, and there was a very tight integration between the language, the libraries, and the proprietary business code. There was already a bit of conditional code in production. I will talk about that later more. And there was a bit of collection of statistics going on. And also there was no dedicated operations team. There was one person that actually had sysadmin in the title. But basically the developers were also running the site and doing a lot of day-to-day maintenance work. That creates a lot of problems. Not just developers are creating problems, you know that, but we had a very long startup time for new developers because there was no formal education or integration program for that. We had rather unstable and slow rollouts because much of that work was done manually. Code was very hard to test because of the conditional code that is enabled for some users on the site, but not all. You have very many variants to test for. And also the code base was also changing rather quickly because of the conditional code. We found new ways of doing things that are successful, that have then been put live and visible for everybody. And basically there have been points in time where the site was changing faster than anybody could keep up. It was pretty chaotic. And also many of the developers were drowning in operations work. And again, there were too many variants. This time, machines set up manually with individual differences that made it also hard to debug things and to roll out new stuff. So we actually stopped hiring for a short time. We made a few decisions and set priorities. And out of the triple of velocity, that is quick development, scalability, grow the site as needed, and performance, bring down the latency for the users, we chose as the primary optimization goal actually velocity, development speed. We also decided that we are not going to make any changes to the site ever, and this is a really hard rule. We are not going to make any changes to the site ever that have not been proven to be business positive. So everything you want to put live for everybody, you need to test first, and you have to show that it actually improves the business, the conversion. And we also needed to make a more formal way of hiring people, integrating them with the way of working. We need to define what is booking actually about, how are we working, what is the ideology behind that. So let's talk about velocity first. This is a typical cost metric that you will see in very many talks about the cost of bugs and fixing them. Basically, if you detect a bug in the requirements and you set the costs for fixing that bug as 1, then finding a bug later in the design stage is 5 times as expensive, and so on and so on. And actually in production, bugs or fixing them can be infinitely or prohibitively expensive, so that you actually live with them and work around them than getting rid of them. In our case, that means that we are not going to make any changes to the production side without testing them first. So we are validating the requirements. Are they actually help improving the business? Are they improving to help the conversion? What is the cost of a new feature in terms of load, or in terms of maintenance code cost, or in terms of customer care load? And we then met another problem, namely that very many people had interesting ideas about what is actually helpful, and these ideas were not actually good. This is a hippo. A hippo is the highest paid person's opinion in the room. That is basically what your manager tells you to do. And we found that hippos are typically not right. Actually, we made experiments about that, and we found that hippo ideas are actually 0% better than random improvements by strangers you pick up in the city center of Amsterdam. That is why we do experiments, because the only way to actually improve the site is to run many experiments. No matter who has the idea of an experiment, the only way to actually find out if it is a good idea is not to look at who's coming with the idea, but actually test the idea. And if you want to get better at testing ideas, it means that you have to run more experiments, because there is no way to actually have better ideas. You just take all the ideas and brute force it. And that is what velocity is about. You roll out code as fast as possible in a controlled fashion, then check out what works, and things that work, you basically fix or re-implement or do whatever else is necessary to run them in a non-insane way. But before you actually try and spend real development resources on something, you have to run it first in a kind of crappy way and try if it actually does something useful for the business. There are other people who have found the same thing. There is a book by a guy called Eric Ries, The Lean Startup, that is basically about this finding and the metrics and the infrastructure you need to sustain that. And I recommend that you read that book and that you also give it to your manager, because it is a really, really useful book. And there are other people. This guy, for example, here has a site called Plenty of Fish, and he's about advertising. And he ran, for example, this ad for a game. Nice in-game graphics, logo, company logo, and he ran this ad. And that is something he came up with Microsoft Paint in 5 minutes. And he actually found that this ad here converted more than 10 times better than this ad in terms of click-through rate. And he wanted to understand better why that is the case, so he generated more variants of the ad. Different colored car, company logo, no company logo, Microsoft Paint influence versus stylish corporate stuff, and he did a full test, all of the variants, and he found that the unusual looking ad converted better than the slick version of the ad. He also found that his target audience, young gamers, actually knew about brands and actively avoided anything that sports Electronic Arts origin. So an ad without an EA logo converts way better than an ad with an EA logo. And that means that brand experience matters, either way. We are doing the same. We have an experiment framework, and that is something that you can put code in, and that then takes a user session and chooses a bunch of experiments that the user is in. And depending on the experiments the user is in, certain code paths are being activated or deactivated, and we then record the outcome of the session. We also record resource usage and a few other things to gather cost statistics as well. And we can also very carefully control the amount of exposure that a certain experiment gets on the site. So we can put an experiment on for, say, a promille or a percent of the users, or we can put it to full on if we think, or if we have proven with a certain confidence that it is business positive. That is also what the Eric Ries book, The Lean Startup, is about. We actually measure things not just at that point in time when the user is on the site and in the experiment. We sometimes, or actually in many cases, also measure later impact. So for example, if you have an experiment that entices user to book a hotel that maybe cannot be cancelled later, how does that affect, as the booking window closes and the stay date comes closer, how does that affect customer care load? That is also an interesting correlation, because it affects your costs of doing business, and you want to understand not just the benefits of experiments, but also the costs that come with it. And these costs are not technical costs, they are also customer care costs, loyalty costs, and other stuff. And the more things you measure with a solid model of a user in your mind, the better you can then estimate what impact a change is having on your site. Running experiments requires that you have a certain number of users on the site. So it is currently rather easy, for example, to do experiments in the browsing stage of the booking experience. But it is harder to do it at the booking stage, because out of so many users, far less users book. And out of the users that have booked, even less become customer care cases. So if you're doing experiments in the customer care stage, you have an even smaller set of users to choose from, and that makes it harder to do experiments. Same thing with, for example, the mobile application. The number of users that are booking through a smartphone and are using the booking application is far lower than the number of users on the site. So experiments do have a higher runtime. You have to have a certain size of business before you can actually start doing this in a useful way. But we are focusing on actually capturing quantitative data instead of anecdotes, and we try to reason about that. And key to that is really a low time to roll out. The most important thing about any idea is to roll it out first and to test it and gather quantitative data of how it performs business-wise before you even care about the actual cleanliness or performance or even correctness of the implementation. If you roll out often enough, most bugs become pretty obvious. You're just tailing the error log, and if you put it on for, say, 1% for 5 minutes and you see the error log starts to move, whereas before it was quiet, you can be pretty sure that something is wrong, and you just take it out without actually rolling back, because it's conditional code. You set the exposure to 0%, and then the code is off, and you can look at it and try to debug that. That's much, much easier than testing. I know other earlier businesses that did similar things, with Freemail, for example, and there it worked in the same way because just the number of users was big enough. It basically means that from here, to get from here to here, you have to have an experimental implementation that tells you if the requirements you have are actually doing something or they are ruining your business. If you have a successful experiment, it is earning money, and normally we are then looking at our estimated capacity at the cost of running the experiment. If the code is inefficient, it can easily cost 25% of performance or something. And we're building the site to have the necessary overcapacity to, for a short time, run an inefficient experiment. We're putting it full on, and then we're putting the performance team on it that tries to optimize or refactor that code and make it non-nasty in some way. But because we're putting serious engineering only on experiments that are already earning money and that are proven business positive, that is actually a useful thing. So the performance team or any other serious engineering is never doing anything that has not been proven to actually earn the money for this kind of stuff. And this gives us a lot better insight than tests, because the best simulation of a real user is a real user. And if you build the infrastructure to roll out experimental code and undo bad changes very quickly without actually rolling back, just disable that, then you can afford to test with real users, at least on a website, because you control the code versions that run, you control the exposure. And there's a term for that, testing in production. There are articles here by a guy working at Microsoft named Seth Elliott, who has been trying to build a taxonomy of ways of testing in production. And in his taxonomy, with the experiment framework, we are decoupling deployment and activation. We're rolling out the code, but nobody enters certain code paths until we put the experiment live for a promille or % or full on. We can ramp up the activation of certain code paths by selecting the number or the amount of users that get into that code path. And we have exposure control. That means we are actually, we know which user was in which experiment down to the customer care level. A customer care agent will see when there is a booker that complains over the phone. The customer care agent will see in which experiments the user was in, and by clicking on certain buttons in the customer care interface, the customer care agent can recreate the exact interface that the booker has seen, and that helps the customer care agent understand a lot better what has been going on or maybe has led to a certain situation. So we control and record what is going on, and we then can do serious math and statistics on that and discuss what the effects of our code changes are based on real users and real money. We also do load and capacity testing on production. That is a common thing that has been going on with WebDE and other stuff as well. We are playing with the load balancers. We are focusing the incoming user load on fewer and fewer front ends until what we're also doing is we put an Apache Siege into the front end, not to generate load, but to measure latency. And when we reach saturation, when we add to the think time, wait time, we see how the latency goes up. Then we have reached saturation. We then increase the load even more, but very extremely slowly until we see failure. And then we understand the failure mode of the site, and which resources we actually exhaust. And then you see the typical hockey stick curves that are predicted by queuing theory in real, and you also see the actual error messages and capacity limits that are on the site. We are also using telemetry. Modern browsers report page load times back in a very detailed fashion, like HTML loaded, CSS loaded, JavaScript events fired, all images present, and so on. And with these statistics and regional data, we can see where we need to put data centers to improve loading times, what CDNs perform better, and what are the data or static content deployment strategies that actually work. And on all of that, we do then a lot of data mining. We do offline data mining. We are starting here to deploy a moderately sized Hadoop cluster to do that better. And for stuff that is run not one-off, to actually find correlation, but for correlations we know and we need regular reporting on, we then have real-time monitors, and these are basically things that run certain queries on a tail or a certain fixed-sized buffer of incoming log data, and is then producing live statistics. And in fact, the entire site is littered with monitors, physical monitors, all over the site, and you can't be a developer and sit there and not see what is the current error rate, what is the current conversion rate, what is the current amount of euros coming in. And if you're doing a deployment and you see the euro graphs doing this, then you'll probably see very quickly that it would be wise to stop the deployment right now, abort, and roll back. And you then know by integrating over that what the amount of lost business is right now for your failed deployment. That leads to scale the method or create more great old ones. How are we dealing with developers if actually that kind of code goes live, and it goes live hourly or even faster? We have a method. Yes, we do have a method, and it's this. This is in Brighton, but you found that in the Netherlands a lot as well. This is something called a shared space. And the idea behind that is something called risk compensation. If you build an environment where people feel safe and get little feedback about what they're doing, then they behave in a way that they try to optimize their own behavior. They basically become more sloppy until they feel a certain level of unsafeness. They feel borders or limits. If you put electronic brake control systems into cars, people will start to drive faster or more risky until the car feels right again, and they get feedback from their touching a border. And what we're trying is to build an environment where people have feedback about what they're doing, and then can try to adjust their behavior in a way that deals with this. So it is not just about removing all traffic signs. Yeah? This is Hamburg, this is Brighton. You see the difference between traffic in a typical German city and in a shared space. This is about education, it's about visibility, and it's about empowerment. That is, when we hire people, we want them to know their trade. What are the possibilities in, for example, my area is databases? What are the options that I have to solve a certain problem? And what we now have is a formal education program that teaches the people that work with that about the choices we made. So out of all the choices that you can do with MySQL, we are not doing the following things because, or we choose to use the following way of configuring things because, and then there's a lot of history, also a lot of experience that we formally teach people about how we work. The other thing is you need visibility. You need to understand who else is doing similar things or relevant things to what you want to change. And you want to see, is the system right now performing or not? and you want the failure mode of the system to be linear. If you're going too fast on the bicycle, you will not, or the bicycle will not fall apart immediately. You will feel that the bicycle goes too fast. It will start to shake, and then you will instinctively already hit the brakes and slow down, because the failure does not kill you, but there are warning signs before that that inform you that you are now entering an area of more risk, and then you take the conscious decision to avoid that kind of risk, maybe because you crashed before at slower speed and survived and have learned that way. So it is important to build systems that behave in a linear and continuous way, and that give warning signs before you actually crash. So basically, don't build nuclear power plants. They have very bad failure modes. But build bicycles. And then you take away everything else that makes decisions for you. If you make a change to the code base, you are going to roll out that change, and nobody else takes that decision away from you. You are going to roll out this. You can ask other people about their opinion, but the decision is yours. You wrote the code. You are the only expert about that piece of code that we have, and so you have to make the decision that this goes live or not. And that is, we give back the responsibility to the person that is actually in the position to actually have an opinion about that, and we give them the resources to learn more or to become more educated or to gather other opinions. But the decision about this goes live or not, that is with the developer that actually wrote that patch. There are rules about that. The first is, if you break it, will you even notice? Do you understand the kind of monitoring that is relevant to your change? Will you even notice if the site breaks because of your change? If you cannot answer that question with a resounding and sincere yes, you have no place in productions. We have a test system, go there. We have classes, go there, learn stuff, but stay away from production. It's not a problem at all. We understand that people need to learn, but if you do not know the metrics for your change, you have no place in production. And then the second is about craftsmanship. If you break it, can you fix it? If you can't fix it, who needs to be present to help you in fixing this? So if you're doing a rollout, get the necessary expertise within reach before you're actually doing this. And then, yeah, fucking do it. Because that's the only way it goes live. So craftsmanship is important, and that's defined as the ability for a developer to debug a certain change, a certain user story, front to back, from business to deployment, and actually understand what they are doing. And we are trying to do that a lot. We sometimes consciously avoid automating certain things. For example, the deploy tool could have a mechanism that would stop deployments if something in the entire chain of deployment is currently broken, if a load test is going on, or whatever. It is very easy to build into the deploy tool a kill switch with a message that says, don't roll out now, we are doing a performance test. We are consciously not doing that because we want the people doing performance tests or load tests and the people that develop and roll out to talk to each other and know of each other's existence and current plans. And if we're automating that, we have a communication problem, and if we're automating that, then we're giving each of these people even less reason to talk to each other. So sometimes developers do rollouts during a load test. Then there's suddenly a certain amount of very engaged and emotional conversation, because basically everything from the load test is now invalid. And that teaches the people from the load test to better understand who's currently planning deploys. And it teaches the developers to actually understand what else is happening with the site and what is important. Yeah, and then we have to redo the load test. It's not that hard and not that expensive. But apparently it needs to be taught, and the best way to teach things is by experience. Failure is extremely important. Yeah, you have to feel the pain of crashing, or you have to feel the water in your face or whatever, to actually take the lesson home. So it is very important to build the processes you have for failure, and to build them in a way that people fail early and in a cheap and fast and easy way, so that they can actually, and in a survivable way, very important, so that you can actually take the lesson home. There are other fails, bad fails, and that are extended suffering and pain, or non-survivable fails, if you don't survive a fail, if you're fired afterwards, or you even die in a plane crash because you made a mistake in the flight controls or whatever, then you are not taking that lesson home. So we are hiring experienced people, because if we hire people, for example, right off university, we have to teach them the goals of the real world and how they are different from the goals that have been shown to them at the university. That's a lot about boring code or crappy code that is earning a lot of money versus beautiful code that is an elegant architecture, but that takes way too long to deploy. And especially if you're on the front-end team, if you're writing code for experiments, the only metric by which you are judged is how fast that is your time to deploy. It is not important that your code is beautiful, because 95% of all experiments that we are doing in the front end are failures for the businesses anyway. So we are throwing away more than 95% of all code that the front end team writes. It is only important that the code goes fast live. And then, after it is proven, and very little code actually proves itself, only then we make it pretty. Or maybe not. Maybe it's good enough and we're taking the hit, because it's cheaper to build a larger site and buy more machines than to actually deploy development time on that. We have the data to make that decision, and sometimes we're making it in this way. And the other thing that we have found to be very important is to hire people that have a proven track record in open source software, because these people have a certain way of communicating and a certain way of handling themselves that makes it a lot easier with our way of working. The other thing that one has to understand when working with software in general is that you're not building new code. This is a lot like cities. Outside of Brasilia and Lelystad, I do not know any cities that have been planned on the green lawn. But every city always is about change or changing existing infrastructure. This is the Teatro di Marcello. It has been built, I think, in 300 something, even before Christ, I think. This part has been built in the 11th century as a castle, and then has been converted into other structures in the 16th and 17th centuries as a palazzo. And currently these are very expensive apartments, and they have even modern infrastructure in there. This has been all built after the fact. And in the middle of the Teatro di Marcello in Rome, there are now concerts. And outside you see 21st century traffic around that. That is very much like software. So code is usually not written newly, it is changed to adjust to new requirements. On the other hand, we, for example, have a lot of code that never sees any exposure after the experimental stage, because it is just proven bad for the business. So we try that out and we throw it away. And working in front end is really humbling or grinding, because you write code and you already know that most of the code is never going to do anything after it has been running in the experiment, because it is bad for the business. You just don't know which code, and that is the thing we are after. We are doing experimentation, we are doing testing in production, we are doing shared spaces. And shared spaces is not just take away all the traffic signs. It is also teach people how to deal with this and give them visibility to see what goes on and to understand which people to talk to, and then build a culture of failure that is build a culture that allows people to fail fast and easy and in a survivable way. Build your technology that way, educate your people that way, and build an organization that rewards clean and good failure and takes away clearly stated learnings from each and any failure. The DevOps message from this is, of course, kill all the sysadmins. The term busted operator from hell is very poisonous in this context, because if you want this culture of failure to actually work, you need to talk to people from the business requirements side all the way through the development process to the deployment process, and that requires a lot of cooperation and communication. And if you are in a bastard operator from hell mindset, you will simply fail very badly in this environment, and you will take a lot of people with you. What you have instead is an infrastructure developer. So not somebody who actually goes to a box and configures code, but somebody who writes Puppet recipes, or who writes deploy tools, or who writes monitoring tools, and then automatically deploys that on a very large number of boxes. Basically, if you have to actually log into a box, you're doing something wrong. You're committing a change, it's being deployed. If you ever have to go to a box to change something, you're doing something extremely wrong, because it means that your deployment mechanism is broken. If you actually have to go a box to read something or look something up, that means maybe that your log collection or monitoring is not up to the task and needs improvement. If you ever have to log into a box, you're doing it wrong. And then there is the in-house operations expert, maybe a DBA or something. That is somebody who has a lot of specialized knowledge about a certain component, like the database, and that supports developers well before and after failure. So the operations expert can tell developers, if you're doing this, it will likely break that way. Or, yeah, you did it this way, now it's broken, come, let's fix it. And again, you broke it, now it's your problem. The BOFH mentality does completely not work here. The infrastructure developer is the opposite of a feature developer. The feature developer makes new stuff, breaks the site in new and interesting ways. The infrastructure developer is not measured by successes, they are measured by their failures. They tend to look at worst cases and outliers. So they don't look at new stuff, they look at how can we kill bad stuff, how can we kill bad slow queries, how can we kill cases where we have abysmal performance or not typical performance, how can we make everything more smooth, and how can we make everything work at, say, 10 times the scale? So how do we have to change everything to make it work at a larger scale? How do we do things with zero manual interaction? If you need to channel stuff through a sysadmin or other person, you're basically serializing things. If you have a change and that can be applied with zero manual interactions, that's the important thing, because then it can be done in parallel. And that's the only thing that scales. And that means that the mindset of an infrastructure developer differs a lot from the feature developer. From the infrastructure point of view, I tend to compare feature developers like with Teletubbies. Oh, you made a change and it's shiny, new feature. Great, well done. And an infrastructure developer is more like a marine. They go in and they leave nobody behind, and then they exfiltrate and do the next thing. It's a completely different mindset, and it actually works with a different method. Feature developers can work time-boxed. Every 3 whatevers, there is a release, 3 hours, 3 days, 3 weeks, 3 months. And anything that is not finished within the time box gets pushed back onto the backlog, and it's maybe done in the next cycle. That completely does not work with infrastructure development because you need the zero manual interactions. So you're instead limiting the number of tasks that are currently in flight. Yeah? For every developer, 2 tasks at most. So if you have a team of 5, 10 things from the to-do list can be active. And they need to be actually in the finished state before you can take a new thing from the backlog and put it on. It's a different, both work with priority lists, but with a completely different way of choosing or managing things. We have that a lot. Everybody works with priority lists, but the feature devs, they work with the time box system. The infrastructure developers typically work with a system that limits the number of things in flight. And for example, the translators, they have a top 10 list. These are the things that are currently hurting us most. Pick any. And when they take something off the list, something else with a lower priority goes higher instead. That is firefighting. That is because there are never enough translators anyway. And everything is already burning all of the time. So what is currently hurting us most, fix that, any of that. And if you have done that, we have another thing that already hurts us. The, say, DBA helps feature developers to understand the consequences of their doing better. probably even before they break stuff. That is ideally. And that enables the developer to make an informed decision. But again, we are not taking away power from the developer. You are responsible for that feature, and that means that the developer chooses to break things, even when they have been informed by, say, a DBA that this is a bad thing. The developer may have reasons for doing that overrule the DBA. The DBA does not own the databases or the data. The dev that is in charge of a feature owns that. And the DBA can tell them what the consequences are, but they cannot stop them from doing stuff. There is a cost with this, of course. Because we depend on testing on production, it means that the changes we do to production need to be so small that we can actually, when something breaks, look at the diff, and the diff must be small enough. If we do not roll out for a certain amount of time, we have a very, very hard time to get back on track. Basically, if you even have to use git bisect to understand where the bug is, then you have not been rolling out often enough. If you are using branches, that is a mechanism for accumulating large diffs, it will not work with this model. So fast rollouts work with write code, see if it compiles, and then push it out to head and roll it out. Everything else is accumulating a lot of changes, and that will make it then very hard to understand how a change actually broke the site. You are dependent on functional and fast monitoring. We have a business level syslog system called event logging. And when event logging breaks, we cannot roll out because we will never see if the site works or not. So monitoring systems become actually mission critical more than everything else to what we are doing. Yeah, we can't use branches. We have problems when we are trying to split the code bases into multiple subsets. We need to roll out a unified code base, and we need to roll out that even to parts of the site that change more slowly, because if the library part of things changes, we still need to roll that out in order to keep these systems up to date. We are very, very active in keeping up to date with, say, MySQL versions for similar reasons, and we are also now active in upgrading to more current Perl versions, and to upgrading to module versions from CPAN, because we have found that otherwise you will have in-house forking of code. People are fixing bugs in modules that are public modules in-house, and they're not giving back these changes to the public code base. That basically means you're left with a fork of something in-house that needs to be maintained, and you will then have a very hard time to ever reintegrate that with advances in the public code base. So it is also very important for us to keep external software up to date and always stay current with this. We are load testing at least weekly because the code page changes very quickly, and that means also that available capacity changes very quickly. We are putting really a lot of awful code live, and that of course has the capacity impact. And then we're identifying that code and we're improving that after we have been proven that it's business positive. And we're doing this by playing with load balancer weights, the load test, by focusing traffic on fewer nodes and understanding it. Culture is important, and it needs to come from the top. And it is not literally what I have heard, but it is basically what I have heard over lunch. Kees, the CEO, has been sitting at lunch with a few people, and there was a new developer. And it came down to basically that exchange. Have you broken the site already? How long have you been here? Yeah, 3 weeks. Have you broken the site already? No. What am I paying you for? Yeah, that is. We have a budget for breaking the site. So a minute of downtime costs that many euros in lost business, and there's a certain budget of minutes or euros of breakage per month, and of course, we are trying to understand how did we break the site, what is the lesson that we can take away from that. But there is a certain loss of business planned in from the top a certain amount of money to spend for this, because it basically educates people. Why are we going to fire you? We just invested €500,000 in your education. That is the kind of mindset that needs to be there. We hire experts. They know about a certain domain. They have Fachwissen. They know about the possible choices. We're teaching them the history, the choices we made, Sachwissen, because they can't know that. That's local culture. Yeah, I already said it needs C-level endorsement, and it needs communication across disciplines. We have developers that are sitting with product owners or business people, and we have DBAs that actually go out of the DBA team, sit with the developers for certain critical phases of development to be available and on-site, and then problems become just a matter of asking something across the table. That is very, very important. Moving desks is very important. And we're never giving the choice back. If you want to change something, you have to decide this is good. You can get counseling or other opinions, but the decision is always the decision of the guy who made the change. Because they are the only expert we have. And that avoids risk compensation. That makes people understand that, well, if you are doing this now and you fuck it up, it will be on, say, Heise News Ticker or Handelsblatt or whatever, if it's a large downtime. And that tends to make people aware of what they are doing and that it has consequences. And that gets people interested in how do things work and how do they interact with things. Or basically, DevOps is magic, because if you treat responsible adult experts as responsible adult experts, they will actually behave like that. And not like little children that need constant supervision. That is the core message, basically, to take away from this. So we are doing very many small projects. We are doing very fast feedback loops. Front end sometimes has a cycle time of less than 3 hours. That is way too fast for Scrum. From a PO or somebody has an idea, let's put it live. And they typically have a cycle time of days, not weeks, for stuff. I work on the other hand of the spectrum. I work in the infrastructure and scalability area of things. So my task is to look at the next year and what do we need to provision and to scale the organization, to teach the people, and to change the technology. So I'm of very few people who have a scope of, say, a year or so. And most of the company, at least in IT, is on a much, much, much faster track. And in order to make it work, you actually have to move desks. You have to work with all the people in a very tightly coupled team to make the transaction costs, to make the costs of clearing up questions very, very low. The primary goal is velocity. We do scalability, we do security, we do performance, but they are secondary goals. The goal we optimize for is velocity. We roll out a lot of extremely badly written, crappy, imperformant, ugly code schema designs, or we break internal rules, whatever. And that's just the way it is. You have to deal with that. Not all people can do it. And I have seen people quit over this. Yeah, because they cannot stand, as a DBA, deploying a schema like that. That's just wrong. Yeah, but it gets the job done to actually capture the data, and we can do it properly afterwards, but most likely we're not going to do it at all, because the experiment has a 90% probability of being a failure anyway. And it's not worth even spending 5 minutes of thinking about making it pretty, unless you know that it's actually earning money. Some people can't work that way, and then they can't work at Booking. Should you do that? Probably not. There are a lot of things here that enable us to do it, and any one of that can make it a deal breaker for you. We are mostly a website still. That is, we control the rollout, we control the version that is running at any minute. We even build the thing open source front to back, from the network drivers to our own code. So we can debug really anything with a deep dive. We usually don't have to do that, but if anything isn't working, we can go from the business side of things through all the Perl layers, through the Apache layer, through the Linux kernel layer, through the network drivers, and debug that. We are a high growth environment, which means that code that runs with us has a finite lifetime anyway. I think we have currently a time to duplication of 15 months or so. We are operating in unknown load regions most of the year because of the rapid growth. And it also means that we are not believers of the cult of efficiency, because we're currently not in an area of the Cinefin model that is cost sensitive. In fact, Slack is good, because if you're in a rapid growth environment, Slack or baby fat is a buffer that, that buffers away growth peaks or unexpected load or unexpected loss of site capacity, because if you actually tune everything for maximum performance, it means you have no buffer. You're always running at the limit, and if then something unexpected happens, it basically means that you break the site. We need these buffers the way we work. That will change once growth becomes slower, but until that happens, we have to run it that way. Should you do it? Yes, of course you should do it. You should treat your expensive adult experts as that, because they perform way better that way. You should kill your hippos with data. That's the only way to kill them reliably. They are beasts. And that means you need to measure, you need to capture real-world data, you need to model and understand what goes on, and then validate your models with data. You need to take your models, make prognoses, and then measure and see if the models actually predict anything useful. And for most of these things, you need to actually be live in order to capture real-world data to calibrate everything else. You need to live by the rules. These are good rules for everybody. Yeah, and because we're growing very fast, we're also hiring a lot of people. That is where to apply. Thank you very much. Questions? Is this thing on? No? But now.
So questions?
How do you deal with configuration changes?
The question was how do you deal with configuration changes? And we're dealing with it in a very traditional way. Even back in olden times when I still was working with WebDE, we did it that way. We basically, if we are doing an incompatible change, for example with data structure changes, we are often doing things twice. We feed data to the old structure, we feed data to the new structure. Was that your question? Or
no, mostly with code changes. Developers roll out new code, they require new tables.
Yeah, exactly that way. Developers need to write code in a way that it can maintain the old and the new structure at the same time. And then we set up a migration process in the background that copies over the data. And even then, we are very often running both data structures in a redundant fashion. We can switch over what is the leading data structure. We are also validating the new structure, the performance of the new structure that way and everything. And only when we are very sure that the new structure can do what it's supposed to do, we are disabling the old code paths. And even later then, we take them out of the code base. So we completely, again, decouple the deployment from the actual change.
But this type of code changes requires an infrastructure expert. This duplication of data, or can this be done by the developer itself?
Most of the time it can be done by the developers. That is also because the developers are the ones that are designing the tables in databases, for example, or that are designing the data structures. It basically gets review. In many cases, it gets review even only after the fact. For example, very often developers will create tables or change data structures, and we do not actually care if they perform. We only care if they perform, if they show up on the radar in the monitoring as bad queries or inefficient structures. Because then they are so bad that they're actually having an impact. We do not really care if something is not beautiful. We care if something is so inefficient or badly written that it's actually showing up on the radar There is also a commit mailing list, and there is a separate commit mailing list for certain modules that are considered infrastructure and to be fragile or important. And both are monitored by coding and experts, Perl experts and DBAs. So if you commit something that touches anything sensitive or that stands out, the code change, the diff will basically be seen, and then you will get the talk. But the talk in this case means it's education. They tell you what you're doing here, why this is interesting, so what piqued their interest, why this might be a bad idea, what could be a possible bad outcome, and then it's your choice to go forward with it or not, in the light of what you have just learned. But again, we never take away the choice from the developer. If you choose to break the site, here's the right button, push it, and it will go offline. And that, again, is the treat people as responsible adults thing. Everybody has been pushing that button at least once, just to see if it actually works. It does, and it usually completely changes their mindset. It happens also during probation, usually, so it happens very fast. And people need to make up their mind if they want to work in such an environment, if they want to actually be responsible for what they're doing. Some people don't want to do that, they need to go away, because it doesn't work that way with us. More questions?
If you roll out a new feature and it breaks something and triggers an error in a rollout from maybe half a year back, which is more likely to fix the new one with a workaround or the old code?
The question is, what happens when we roll out new stuff and we roll out older changes with that? And you specifically said half a year. We are very actively trying to avoid that. We need to roll out fast. We are completely dependent on changes from one rollout to the next to be very small, to make it easy to debug and for the code to be relatively fresh. We also require for a rollout that everybody who has a patch in a diff that goes live is present during the rollout. So if your code is part of a rollout, you have to be online on a production Java channel for emergency calls before the thing can go live, basically. That's the same thing that Facebook does, and it works very well.
Yeah, but I meant if a new rollout triggers a bug in a rollout that was...
Oh, in a previous... yeah.
Do you make the new code to work around the old bug, or are you trying to fix the old bug?
The first thing that we do is actually we roll back. We can do that in 8 seconds. Because the old code base is still present, and we just have to change the pointers, and then we have to repoint plug to start the new daemons, the new worker daemons on the old code base, and then everything will be as before. And then we make decisions, and that is then done without time pressure. We also decouple activation from deployment. As the bug you have is not the compilation problem, the code will be rolled out, but it will be inactive. And then the exposure control from the experiment framework says, give it a promille and see if the error log moves. And that way we don't even have to roll back, we just turn it off again. And that single thing, separating deployment from activation, is a very extremely powerful feature that I can only recommend to everyone, because it takes away the stress of a deployment completely, and it gives you much more control about how to break things and how hard to break things. You can make a lot better informed and a lot more controlled decisions that way. And then you can take the actual decision-making process offline, out of the deployment process, and make it without any stress, with looking at the diffs, with looking at the problem, and coming up with better strategies. But separating activation from deployment, that's, I think, a key learning here, and a thing that a lot more people should be doing.
Okay, then I would break it, because then another one has 5 minutes to be prepared for the next talk. Thank you very much for the great opening.
Thank you very much.